Thank you so much for joining us. Looks like we got a couple more people coming in. But thank you all for joining us at Sculpting Data for Machine Learning with Jagyasa and Rishab, who are senior machine learning engineers from Twitter. So if you are interested in engaging with this talk as we go through, please go to the Coalesce Sculpting Data for ML on Data Slack. Please ask any questions there. We will be pinning those and ensuring that the speakers can address that for about an hour or two after the talk is finished. With that being said, let's welcome up.
Thank you, everyone. I'm Jagyasa Grover, and today we'll be talking about how we can sculpt the right kind of data for our machine learning models. The last couple of years have seen an immense growth of machine learning in multiple domains, from influencing our shopping car lists to cars self-driving themselves around the town. Unquestionably, machine learning is the most used and the most abused subdomain of artificial intelligence presently. It is being wielded in improving healthcare as well as advancing the warfare, in scrutinizing your resume to determining your creditworthiness, in creating music and meaningful lyrics, to synthesizing pictures and videos of people non-existent on this planet. So regardless of our fascination or loathe for it, it is influencing our decision-making power and dominating our lives heavily. These dominant leaps are leaving scientists, policymakers, inventors, business leaders, and the audience bedazzled that human-like intelligence is just around the corner. Nonetheless, progress in machine learning has been very impressive, but there's a lot of pending explanation and examination which keeps the research going on. For the state-of-the-art machine learning algorithms to work their magic, it is very important to focus on three key dimensions: well-calibrated data, sophisticated algorithms, and efficient computation. Sophisticated algorithms usually come with iteration and experimentation, and you can always keep on adding, layers to your deep neural network. Efficient computation, on the other hand, the more machines you provide, the more GPUs you can provide, it is very easy to get those resources. But what is the trickiest part is the well-calibration of data. So, and since we have progressed a lot from the rule-based approaches to more data-driven approaches, it goes without saying that machine learning algorithms are trained to capture implicit information from the vast sea of data that we provide. It is true in a sense that these approaches are very data-hungry. So without going into a lot of details, if you have a deep learning model, there are so many parameters that need to be tuned, and therefore a lot of data is usually helpful in coming up with somewhat generalizable model. So in that case, having a lot of data is the key to coming up with good quality data sets. So if you look at this pyramid, so this was drawn by Monica Rogati, who's a well-known data scientist and AI advisor. So this is drawn parallel to Maslow's hierarchy of human need, and it is called the AI hierarchy of needs. So Monica puts forward that, at the very bottom, data literacy, data collection, and data flow, these form the basic needs which must be satisfied for us to achieve self-actualization, or for us to achieve nirvana, which in this case would be the attainment of AI. And the type of data that we feed into these algorithms has a profound effect on the success of the algorithm. Garbage in, garbage out is something that we should keep in mind. And with that, so we know quantity helps, and now we also know quality also matters, because Peter Norvig has put it in a very simple way that more data beats clever algorithms, but better data beats more data. So machine learning models are as good or as bad as the data that you have. Let's talk about academia. And all these core machine learning and data science research groups in academia, they are more oriented towards novelty and advancing the field. Many a times they weigh this newness of the problem-solving approach more than performance scaling or even money-making logic. And in this attempt to work on new problems, finding collaborators from pertinent domains, and seeking funding for the research, they are not the only obstacles these groups face. They also have to look for relevant data sources, like vast sea of data where they can procure from, because there is absence of in-house data, and this is contrary to corporate giants like Facebook, Twitter, Google, which have like tons of data at hand. So these established organizations, they seldom have obstacles in obtaining computation power or like hiring folks with the expertise in corresponding domains or even accessing relevant data. For them, the challenge is scaling up their solutions to their massive user base. And any organization with tons of unstructured data at hand, in forms of raw logs, sensor data, user data, they need efficient data processing pipeline. And for creating such resilient pipelines, apart from the tech knowledge or the tech stack that you have, we also require skills to identify and curate meaningful and unbiased and robust data sets from the sea of unstructured data that we have, so that they are easily ingestible by any state-of-the-art machine learning algorithm. So this is an approach to data-centric AI, and I'll let Rishabh talk more about this.
So the main focus of this talk is about like how we can like source our data sets, where to look those data sets from, and essentially how to kind of groom them to ultimately make them worthy of training high quality machine learning models. So we'll be giving some color regarding that soon, but before we talk about that, I want to go over some of the data sets we have collected, which are publicly available on Kaggle, and they're doing well. And we want to make like several points, taking examples of these data sets. So the first one is the clothing fit data set. We collected this from ModCloth. So this data set contains fit feedback from customers regarding their clothing purchases. So it has other attributes like reviews, ratings from them, measurements, and so on. So we collected this data set to address size recommendation problem, which is about whenever we go to, let's say, e-commerce website, we are looking at a clothing product, like which size would fit me the best. So that's like the problem that we wanted to tackle and collected this data set for. So next one is Sarcasm Dataset. So most of the previous studies in this domain used Twitter-based dataset. So there the problem was they were very noisy in terms of labels and language. So we identified these two sources, the Onion and HuffPost. So the Onion publishes sarcastic news, whereas the HuffPost contains like real authentic news, to kind of build up this high quality data set for this problem. And the last one is news category data set. It contains news headlines, preview text, and their corresponding categories in which they were published. So that, yeah, so we'll be talking about the utility of it like later on. But we collected this data set without having any specific problem in mind, and we'll be seeing how that kind of helps in kind of making unique contributions to the community. So these data sets are kind of available on Kaggle, and they're doing well. So feel free to check them out later on. But so now I want to circle back to how it relates to kind of searching for relevant data sources. So there can be like two types of paradigms. So first one is like guided search. In that, we have, let's say, a specific problem in mind that we want to solve using machine learning, but we don't have specific relevant data available to us. So I'm kind of curious, like how many of you have kind of faced this kind of situation where you want to try something but don't have data? Yeah. So yeah, quite a few. So this has been like becoming like a bottleneck in applying various like machine learning techniques. So hopefully that will be helpful. So next, I think yeah, we can go into this and talk about this paradigm, and also the main challenge this paradigm kind of presents. So if we have, let's say, a specific problem in mind, and we are looking for a specific data set for that, the main challenge there is understanding the problem in and out so that we can identify unique sources to procure our data set from. So in order to approach this paradigm, to search for data set for this paradigm, the first thing we need to do is define the problem formally. So let's take an example of size recommendation problem. In that case, we can say that given a user and a product, given a user and a product with different sizes, we want to recommend the user a size of the product which will fit them kind of perfectly. So that's essence of the problem that we are trying to tackle, and kind of lays out all the factors that goes in to kind of solving this problem. Now, once we have the formal definition in place, we have to identify, let's say, what are the essential data signals we need to look for to address this problem. So again, circling back to the size recommendation problem, from the formal definition, we could identify that, let's say, we absolutely need user ID to uniquely identify the user, product ID, the size the user has purchased, and what was the fit feedback of the customer on that product. So these are kind of absolutely necessary in order to address the problem. We could certainly have other types of data category of the product or the price, but these are not absolutely necessary, but kind of good to have. Now, once we have identified the essential data signals, that will kind of focus our search as we are looking for data sources on the web in identifying which sources could be kind of promising and which we could just eliminate. Now, another aspect comes in while navigating the source of the data set is the data volume requirement. So as you might imagine, these days, Jigyasa mentioned, that the models are kind of data hungry. So we need sufficient volume of data for it to be kind of useful for machine learning models. So we have to keep in mind, let's say, if you're trying to collect, let's say, clothing fit data set, we have to look for e-commerce websites which have sufficient reviews regarding certain products and their fit feedback for them to be kind of really useful for us. So these were some of the pointers to kind of go through while looking for data sources if we have specific problem in mind. Next paradigm is, of course, everything else where we don't have any specific problem in mind. And this is kind of really kind of interesting because we always thought of contributing to machine learning in terms of, let's say, developing some methodology or another interesting way to kind of train the model. But contribution of data sets is also one of a great part of it. If you can enable people to kind of address different types of problem by providing high quality data set, that is also really valuable. So now what's the main challenge in this paradigm? The main challenge is kind of uncertainty because we don't know what we are looking for. So hopefully the following pointers that we are trying to provide will help kind of narrow down the search of it. So first thing we need to look for while, let's say, we are searching, going through various websites and things like that, we can keep these pointers in mind to kind of narrow down what could constitute as a high quality data set. So first thing to look for is whether the data we are collecting, whether it contributes any data signal which is kind of worth estimating or could lead to kind of fascinating results. So the news category data set we collected falls into this category. So if we think about what we could do with a bunch of news articles and the corresponding category in which they were published. So we can certainly kind of train a classifier on this kind of data set that can identify, let's say, any, hello, sorry, any writing style of the text. So let's say whether it's like political, it's entertainment related, sports related, and things like that. So this could be certainly really valuable in natural language processing domain. We could also tag untracked like news article that is like a immediate practical value it could provide. So these are like some of the things we kind of thought about when collecting this news category data set. Now, apart from that, once we have cleared this first hurdle, we also have to think about whether we have like sufficient metadata associated around, let's say, the main attribute that we are trying to collect for. This certainly helps in like training good machine learning models. So feature engineering is like a part of machine learning process. So if we have sufficient metadata around the main signal, for example, let's say if you are collecting data for like clothing items, it could be, let's say, brand of the product or the price of the product. So those could certainly help in engineering more informative features, which will ultimately be helpful for our machine learning model building process. Now, the data volume requirement is here as well, but it's kind of slightly relaxed in a sense that we are not kind of restricted by a specific problem. So to take an example, let's say in news category dataset, we had certain categories which had, let's say, less than 100 articles. So with this much less data, we certainly can't train like a reliable machine learning classifier. So it'll be best to kind of just remove those and only contribute high quality and large quantity of data so that it's kind of valuable to any person who is kind of using it. And lastly, this is like a given thing, but we also have to check the uniqueness of the data set that we are kind of building. It's kind of parallel to any machine learning technique that we may develop, right? So we have to identify the unique USPs of the data we are collecting and use that to kind of promote our data set so that more and more researchers may use that. So now shifting gears, like collecting data is just one part of the puzzle. Once we have the raw data, our job is not finished, and like we still have to kind of groom the data for it to be useful for our machine learning models. So I'll pass on to Jigyasa to talk about like various ways to do that.
So yeah, we talked about how we can use big websites to collect our own data set, which is also another way of contributing to the machine learning community, not only just advancement in architectures or ways to optimize the training process. So once you have collected the raw data, let's say you can use tools like Python, Selenium, Beautiful Soup, etc. To collect the data set, let's say in a CSV format or a JSON format. But just extracting the data is not enough. We have to work on the extracted data to do processes like eliminating impurities that might have crept in before you feed into the machine learning model, which again brings us to the same point we said, garbage in, garbage out. So you have to like really sanitize the data set that you have created in order for us to directly feed it into a machine learning model. So you can think of it as grooming the data set. So our data would not help a machine learning model, no matter how sophisticated our model is, if the essential data signals are missing. So talking about the fit recommendation problem that we were talking, given a user ID, given a product, we want to recommend a user the perfect size they should be selecting before putting it into their cart. So let's just imagine for a given product, we just don't have and a user, we don't have the size they purchased previously. So if we don't have that data, how would we move forward? Like, we don't have historical aspect to that, considering this is not a cold start problem. So this process of excluding specific values due to their irrelevance, redundancy, or extremity from a data set is called data trimming. You just trim out the data that you don't need any of the transactions. So this is something that you could do. And the next thing is, once you've removed the transactions or the data points you might not need or might not be helpful since they are missing the essential data signals, is data integration. In an ideal scenario, what we would assume is that we just take one data source, you collect data from it, and that's it. You would get the perfect quantity of the data with the perfect essential data signals that you need. However, this is a very classic example of expectation versus reality. So coalescing, the data from separate sources to provide a unified view is what we called data integration. You can do data integration in two ways. One is vertical integration. So recalling the previous example of the sarcasm detection dataset dataset that we created. So we used two different sources, the Onion and the HuffPost. The Onion because it provided all the sarcastic examples, whereas the HuffPost because it provided all the real examples. However, the attributes we collected from both of these sources were the same. The link to the article, the headline, and a simple label which said, is it sarcastic or not? So with these three attributes, if you join along them, it's easier to connect because the attributes were the same, and that way we were able to create a balanced data set vertically by integrating it vertically. The other example could be of horizontal integration. You can consider of a task where you have to build a data set regarding different cities globally, and with specific fields like state, country, area, population, climate, civic administration, religion, languages, festivals, etc. And it is very highly probable that you would need to refer to multiple sources. In that case, you would do the classic join, which is take certain attributes from one source, take certain attributes from the other, and join them based on the city ID that you would have. This is horizontal integration. And all this needs to be done because we want to have a balanced data set and provide biases to creep in. And this is, again, an example not only for creating a robust data set, but also having unbiased to have balanced ones. So the third example could be of data transformation. And since we know there's tons of content available online, and it is impossible to check correctness of each of it. Let's taking the example of this clothing fit recommendation. The content which would be posted by a publisher, the name of the product sizing, product description, these all things are something that can be moderated to an extent. But what about the user-generated content? The content about reviews, people can write random languages, people can use short forms and emojis and whatnot. And you cannot directly feed them into a machine learning model, even if you have an attribute which says reviews. So the necessary thing would be to scrub the data set, using specific techniques to produce the quality data set. And you can do it by handling special characters, removing them, handling the grammar, doing spell checks. Also, different words could be in the same, or doing lemmatization or stemming, other NLP techniques, like wearing, wore, wear. All these things mean the same and the model is not able to categorize them as same unless and until you program it or tell it to, or encoding the sizes in numerical order. So all these things are cases of data transformation that you can do. And once you have removed all these impurities from your data set, that is when you come to feature engineering, which Rishabh was also referring to, bringing in metadata, bringing in encoding and other embedding techniques. If you think of data as the crude oil, features are the fuel we need for machine learning models. And it is one of the key techniques that often does not get its due limelight. Much of the success of machine learning is actually success in engineering features that a learner can understand. And this is where the intuition comes in play, along with creativity and experience in different domains. So you have to really think from user perspective on what signals might be helpful. For example, for the clothing fit, it is very necessary to have metadata, for example, the fabric of the product, because there are many fabrics that might be stretchable or not stretchable enough. So these things that really come with experience or thinking about the problem other than, oh, just put it into a machine learning model. So this step can be actually much more important than the model that you use. As we said, machine learning algorithm is only as powerful as the data that you provide it. Choosing the right features in right format can by far boost performance using simple ML models. Consider a data set that you directly feed it into a machine learning model, and a data set on which you've done enough processing and feature engineering, it is highly likely that it will perform much better. It increases the transparency of the model, and much more, it increases your understanding of the model and reduces the need to do heavy, complex ensemble learning techniques. And also, it reduces the need for tuning hyperparameters every time you change any attribute of a data set and their optimization. That being, the bottom line is there are so many processes that need to be done before data becomes really ready for a machine learning model. A typical workflow looks like this. You start from thinking about a problem, fabricating data source, machine learning models, thinking about the success metrics, and deploying and productionization. In the past many years, the entire focus of all the companies and organizations has been to choose what kind of sophisticated algorithm I can use, or what would be my metric for success, which relates to product metrics, and so on. But the real impact is that data affects us all. So the focus should really be on sourcing the data, creating the right features before putting it into a machine learning model. So this is what the premise of data-centric ML is. Andrew Ng, who is the AI advisor and AI guru in today's world, also tweeted out, I guess almost a year ago, that machine learning is nothing but code plus data, right? And all these competitions and research is always focused on coding aspect of it by keeping the data constant. Even if you go and participate, let's say, in a very simple university level competition, they'll give you a data set and then say produce 90+% accuracy or something. They always focus on, oh, here's the data, just make a model out of it. But the actual is you should be munging the data, you should be massaging the data so that even the simplest of machine learning model is able to give you fascinating insights out of it. That being, we've also published a book on this. These were just a few of the pointers we shared from the book. It's called Sculpting Data for ML, and it really acts as the first act of machine learning. You can find code examples right from scripts in Python, Selenium, Beautiful Soup, step-by-step on how you can create a data set of your own. As you mentioned that you have trouble getting relevant data, and you might think, oh, I know a perfect source, all I need to do is create data set out of it. This book might be really helpful. It is endorsed by leading ML experts, both from academia as well as the industry. So we have Julian Macaulay from UC San Diego and Lawrence Moroney, whom I guess many people know. He's the lead AI at Google. And with that, thank you so much. Open to questions, and we'll be here, or you can find us on Slack. Thank you so much.